Okay, in the last video I showed you how to make an electromagnet, and we had a little bit of a recap on the practical from year 8. This one I'm going to explain why electromagnets produce their own magnetic field. Now the answer is quite straightforward really, and the bottom line is whenever a current passes through a wire, a magnetic field is produced. That's as simple as it gets. Now I'm going to show you first, I'm going to show you two examples. The first current carrying wire is a straight one. So here we have a piece of kit. This is from Philip Harris, the vertical wire. And as you can see here, there's two sections of this wire that are vertical. Now it's on a Perspex stand so that we can see what's going on around it. Now I'm going to show you that there's going to be a magnetic field around, well there'll be around both, but I'm going to show you this one here. So there's the vertical wire there. You're not going to be able to see the vertical wire because we're looking directly from above. But if I place it here, now we've got DC power supply. I've actually got a rheostat or a variable resistor, because if I connected this short section of wire to the power supply, it would trip. The current would get too high very quickly, and there'd be an automatic cut-off switch. So the variable resistor just limits the amount of current that flows through the wire, so it doesn't trip the power supply. Got an ammeter. It's always good to have an ammeter there, just to show us what sort of current is going to be flowing in the wire. And going to connect the piece section of wire. We're going to measure the magnetic field in series with the variable resistor, the ammeter, and the power supply. Okay, right, now the thing I'm going to show the magnetic field with is the thing we plotted the magnetic field around the bar magnet with, and that is our friend, the small plotting compass. Okay, now if you remember from the last video, north is that direction. Okay, so if I have the plotting compass, I've got two here, and if I just hold them, okay, there we go, they're going to be pointing north, which is in that direction. Now if I place it down here, again, it's going to continue to point north. But this is what I want you to see. What's going to happen when I turn the power supply on? So it takes a while to come on. This is what we're waiting for here. Right. Now, as you should have seen there, the needle suddenly flipped. Now, just like we did with the bar magnet, if we were to trace the direction of the field lines, we'd see that they are circular. Okay. Now, if I was to get a number of bar magnet of plotting compasses, you should hopefully see that the field lines are circular. Now, if I turn off the magnetic field, so if I turn off the electric current, the magnetic field disappears, and the four compasses go back to pointing north. If I turn on the current, waiting for this to come on, if I turn on the current, then the magnetic field takes over from the Earth's magnetic field and shows those circular, that circular field pattern. Okay. Now, if I wanted to trace out, the field lines, they would look circular, like this. There you go. Right, now which direction? There's a rule here. There's always a rule, but there's a rule to show us the direction. Now, can we see that they're looking down? The field lines are anti-clockwise. the field lines, so the needle is pointing in the direction of the field. So the field lines go in that direction. Now there's a rule for predicting the direction of the magnetic field around a straight wire, and that is called the right-hand grip rule. All you need is a right hand, preferably your own. And then you have the wire here. Now, the fingers, the thumb, shows you the direction, or the thumb aligns with the direction of the conventional current. Remember, conventional current goes from red all the way around back to black. So the conventional current is going in, the conventional current is coming up this section of wire. Now, the fingers, which seem to be gripping the wire, they point in the direction of the magnetic field lines. So there you have it, the magnetic field around a straight wire. The field lines are circular, and the direction of the magnetic field lines is predicted with something called the right-hand grip rule, where the fingers are the direction of the magnetic field lines and the thumb is the direction of the conventional current. Thank you.